Hey guys, GM. So welcome to the stream, and today we will be trying out reading through Aave's code base. Before that, let me just get everything working. Renting and tooling, yarn, and then we install through yarn. So I know not too much about Aave, so I just know that it is a lending and borrowing protocol, and on top of that you can get yield. So I was thinking about creating a video on Lido, but since I wanted to stay on my goal, right? So I dropped the idea of that, and instead I am on like reviewing Aave, which was in my list given by the Shafu. So there was a tweet from Shafu, for those of you who don't know. So I am just following. So this series about uh, running, so not running, but reviewing the code bases of multiple projects is inspired from his tweets. So so let's just compile. If I can do that. Yep. So let's go. I think we are all done and dusted. So before we go ahead and review the code base, I think it is good that we go through their docs, understand what is mentioned there in their architecture, and we are specifically reviewing the code base of v4. And so I think it is better. I don't know anything about v4, so I think we should definitely go and learn, and then we can take it from there. So about Aave, earn interest, borrow when you need 24/7. They have supply and borrow, so you can earn interest by supplying assets to the lending network, and you can borrow against the collateral. And why choose Aave? 12 networks. Okay, stable coin supply. Okay, so you have earning like a motive to earn interest by lending. So you can swap assets, even those borrowed or supplied. Okay, save save and earn yield with the Aave's native stablecoin GHO. Okay, so there is GHO, and there's yield, like there's yield on GHO, and there's yield on by lending. Easily track, see the security, bug bounty. GHO is a centralized stablecoin. Okay. So let's sorry. So let's just there's a lot of grounds to cover here. So I'll like quickly jump and understand what is needed for us to understand the code base. So get familiar with Aave. I think this should be the same, right? V4. So we are reviewing concept, getting started. Okay, liquidity model, user positions, tools, references. But I'm curious about whether we should understand v3 as well. Would that actually help us or not? There's no concept, right? Reserves, liquidity pool. I think I'll go with the concept section of v3, and apart from that, I don't think we can just stay there on the What is this? Markets. Does it have markets? It has liquidation model getting started. This is interesting. And this is part of Aave Earn. Okay, this is part of. Okay, let's just go. Let's just start at least, and from there we'll see if we require if we need to understand v3 as well. On new Aave Kit repo. Users can participate as suppliers, borrowers, blah blah blah. Okay. So that's okay. Aave is a leading liquidity protocol. Aave is a leading protocol, liquidity protocol, a decentralized system of smart contracts. Slates the efficient movement and management of digital assets built on supply and borrow model. It enables users to supply liquidity and in return allows other participants to borrow against supply collateral. The protocol is deployed across multiple blockchain, ensuring the accessibility and interoperability across networks. I always like. I think it should be the ability to okay. It's like interoperability means that ability to connect with other systems, basically. Defining characteristics of decentralized liquidity protocol. Whether it's okay, I am streaming. Yes. Where was defining characteristic of decentralized liquidity protocol is in its non-custodial design, that you get ownership of your assets, basically. Which ensures users always retain control of their assets. All operations are handled by permissionless smart contracts. User control, direct interaction using a self-custodial wallet without. Okay, I'll just mark it. Okay. I think there was a short, yeah. I'll just do this. Is it so it user controls direct interaction using a self-custodial wallet. Transparency, all rules like collateral requirement and interest rate are embedded in open source. Okay, collateral requirements and interest rate are open source. I mean, publicly available. And trustless execution operations are executed automatically without drilling. Okay, how it works. I think the biggest problem in understanding the protocols that are dealing with the markets are like basically this understanding of what is liquidations, how things are calculated, right? The calculations matters a lot, and I think I'm going to understand. I'm just not going to walk over them, but I'm truly going to utilize the time in understanding the mathematics and rationale behind choosing a formula thoroughly. Yeah. So how does collateral works? In decentralized finance, lending is secured by collateral. The digital assets a borrower locks in the protocol to secure a loan. Unlike traditional finance, which relies on credit scores, DeFi uses over collateralization, which basically means that you need to deposit more in order to get some amount of money out. Like if you deposit $100, maybe the loan to value would be like $80. This requires borrowers to supply assets of greater value than the amount they wish to borrow. This model is essential for trustless system because it's decentralized, of course. It protects suppliers' funds and maintains a protocol solvency by ensuring there are always sufficient to cover the debt, even if the value of the collateral decreases. Lending and borrowing. The Aave protocol function as two-sided market. Users can participate as lenders and suppliers. Borrowers are both lenders. Borrowers are both. Interest rates are. Interest rate adjusts based on how much liquidity is in use. So utilization factor basically, and interest rates are basically dependent on how much like what portion of the total liquidity is being used. Aave uses a utilization curve with a kink at a target level. This uses a utilization curve. With a kink at a target level, below the target borrow rate increase gradually. Below the target, at a king with a king, borrow rates increase gradually. Above it, they increase more sharply to protect liquidity. Okay, this is very interesting. I have no clue on how. So I'll just mark it with pink just because I don't understand it fully. How is this supposed to work? How is this supposed like? Yeah. And liquidations keep control. Keep the protocol solvent by correcting risky position. When a position becomes unhealthy, a liquidator can pay a portion of the debt and receive collateral with the liquidation bonus. Can repay a portion of the debt. Beyond its core market, Aave includes complementary features and extension. Streamlined actions such as token swap and native components like GHO stablecoin. Okay. Let's understand Aave v4. Interesting. So, I am not sure whether we really need to understand v4, v3 or not, but anyways, I'm going to give it a try because it is more about like getting close to the problem and solving them, right? Which makes you a good developer as well as an auditor. Because prior to this, I used to be in a loop of tutorials. Like I would look out for tutorials and all, and before that, I would not start. But I think this should be a good start. Yeah, let's see how it goes. So Aave v4 uses a hub and spoke model for liquidity management. Hub and spoke. Okay, I'll just bookmark it. The liquidity hub consolidates protocol. The liquidity hub consolidates protocol wide liquidity and accounting. Okay, while spoke implement modular borrowing with isolated risk. Okay, I'll just highlight this as well. So I think what it means is that the liquidity hub. Wait a second, just give me a second. Okay. Oh, wait a second. I'll just like close this. Yeah. Okay. Wait a second. So, um, the liquidity hub is basically used for keeping track of liquidity and other accounting uh, nonsense, while the spoke is more like carrying the weight of tracking of borrowing. I think that is it, right? Let's just, so liquidity hub is basically this, and okay, so borrowers. Okay, so let's just give me a second. I'll just create text here, liquidity hub, and what was the name? I think it was spokes. Okay, like weird choice of names. I think it's not really convenient. Liquidity hub tracks all tracks liquidity and what was it, and accounting the spokes basically implement modular borrowing with isolated risk. Spokes implement modular borrowing. Okay. Yep. Liquidity hub is the central liquidity source. So the liquidity hub is basically the center of like one source for liquidity in V4, and it maintains credit line and debit line. Credit line basically should be like how much borrowing is allowed, or how much what is the cap for supplying in a particular spoke. The hub enforces system-wide accounting. Yes, that is it. And caps how much liquidity. Centralizes liquidity and accounting issues per spoke, credit debit limits enforces system-wide constraint. Yeah. So yeah, this is good info. So it tracks. It issue tracks. Tracks. Yeah. And then we have hub assets. Hub assets are like hub assets. Hubs are liquidity hubs, and then the assets are these Ethereum, Bitcoin, and all. And okay, hub assets are ERC20 registered. In the liquidity hub, they form the shared liquidity that spokes borrow or supply. Okay. And spokes are modules that manage specific borrowing use case, assets, or risk profiles. Spokes are modules that manage specific borrowing use cases, assets types, or risk profiles. I don't really understand what does borrowing use cases means here specifically. A user interact directly with spokes, while spokes draw liquidity from the hub. Local control, supply caps, independent accounting per spoke. What does it manage? I forgot. Asset types and risk profiles. And risk profiles. Users interact with spokes while interacting with liquidity, I believe. This is how you can try it. Yeah, and so here there are some restrictions. So in liquidity, how we can set how much has been what is the max cap of credits line for like credit lines for spokes, right? It has a universal accounting within the liquidity hub itself, but in spoke we have also local controls of the supply caps and emergency stops. So it is good to make note of that. It includes local control accounting. Yep. Yep. Yeah, fair enough. It's reserves is basically how much, um, what are the amounts of tokens available within a pool. Here will be liquidity hub. How hub assets is like how a hub is borrowed within specific each spoke sets its own reserve like supply caps. Mm. So reserves basically is what I said earlier, and each spoke have his own reserve parameter, which we also read through in like the above the section for spokes, and it has parameters like supply caps, how much the user's supply can reach, and borrow caps, how much borrowing is allowed, and risk settings. And while the hub ensures, while the hub, which is where the liquidity resides, ensures that all liquidity stays within system-wide rules. Okay, so spokes are modules that basically have cap restrictions per assets, and a hub is basically where the liquidity uh, is there, like present, and it also has a counting mechanism, and yeah, let's understand interest rates. Borrow and supply rates are determined by utilization curve. Utilization measures how much of an asset's liquidity is currently borrowed, expressed at borrowed multiplied divided by total liquidity. It's utilization, right? Borrow and supply rates determine borrow and supply. Okay. Utilization measures how much of an asset. Okay, let's write it down ourselves. Interest rates are defined by utilization rate, so how much? What would we write here? Borrowed. Total. optimal usage ratio, the borrow rate increases gradually. Above it, the rate increases more sharply. The supply rate, so borrowing rate increases. Okay. The supply rate is derived from borrower's interest after protocol fees and reflects. Uh, yeah. So the borrow rate increases, like the amount of money that you need to give as a premium for borrowing assets increases gradually if it is under like a certain like a point. It moves gradually, like till that point, which is mentioned here. It's mentioned that below an optimal usage ratio, which is how much, I think this point is derived from the like utilization ratio. The borrow rate increases gradually below. Above it, the rate increases more sharply. The supply rate, and also this is the borrow rate, and the supply rate is derived from borrower's interest, how much the borrower is paying after the protocol fee, and reflects supply. Okay, let me just bookmark it. So we are talking in the first point, we are talking about the borrow rate. The second, we are talking about the supply rate. So the borrow rate is how much the borrower is paying, and the supply rate is like how much the liquidity provider is getting. The supply rate is derived from borrower's interest. Okay, let me write it down, that'll make more sense. The supply rate is dependent on is derived. The supply rate is derived from borrower's interest. The curve is defined by a base rate, slopes below and above, slopes. The curve is defined by a base rate. So the curve we are talking about is the curve below the, like, a point below a particular utilization point and above. So it is defined by a base rate, like how much it increases per, like, at some point. Slopes below and above the, yeah, within either below or above, okay. And the optimal uses ratios itself. I really don't understand this. So let me just, no, not this. Okay, so what it is saying that we define a base rate, and till the moment the slope reaches a optimal point, right? Uh, the rate increases, uh, like uh, like uh, like in smaller steps, but after uh, the minimal, optimal, sorry, not the minimal but the optimal point, the the rate increases very heavily. since it is basically reflecting demand and supply. And the risk premium is basically an additional cost that the borrower basically has to bear on top of the borrow rate if the assets that they are providing as a collateral um, yeah based on the quality of the collateral. Yeah, it is a percentage such as on top of the shared borrow rate for that asset. Yep. A user position is the combined view of what a user has supplied and borrowed within a spoke. User position is a combined view of what user has supplied, as in like be it as a supplier or be it as a collateral, and what they have borrowed within a spoke. Spoke, as you can recall, is wait a second, just give me a moment. Yeah, sorry. Yeah, so uh, yeah, so as you can recall, spoke is basically where all the accounting is stored, and it defines maximum like users need to interact with spoke, and basically it has accounting like the, for example, uh, like max cap on the borrowing, and it'll then interact with the liquidity hub. So yeah, I think this is right. Let me just go back. Spoke manage assets. Yeah, it manages assets types. User interacts with the spokes while these monitored. Okay, independent accounting. Yes, yeah, that is it. And we don't need to actually remember it as of now. It is okay to forget, because we are creating notes for recalling purposes, right? So it doesn't matter. Yeah, and positions are tracked per reserve. So reserve is basically, you can say that liquid, like the amount of, I think into like basically you can call reserve, you can call how much liquidity you have provided. Health factor reflects position solvency and indicate how close a position is to liquidation, calculated as eligible collateral value, debt value. Users must stay above 1 to avoid liquidation increases when debt is repaid or collateral value rises. Interest occurs. A new debt is taken. Okay. So yeah. So let's just take a note of this as well. Where was it? Wait. Stay above 1. That means make it more wider. Increases when we pay on the value of the collateral. do you spell it? Oh my god. Yeah, so we have an explanation to health factor as well. Manageable. So I think basically to summarize, right? So health factor is health factor is basically defined as a formula of how much what worth of collateral you have provided, and what how much you have taken against, right? So that defines um, the health factor basically. So I think we don't need to understand this, or should we? I think we don't have to. Yeah, I'll take a quick break of 5 minutes and then I'll continue. Hey guys, so took a short break and we are back. Yeah, so we were reviewing the docs of Aave, and now I'm reviewing the integration side of Aave. Yeah, I think it's not necessary for us to understand it. Yeah, so yeah, so we are now reviewing liquidation model, and apologies for the background noises because there's some work going on. Okay, so let's understand the liquidity model of Aave. Uh, so, does this reserves? I think this basically means, what is that? Okay, reserves. The orange one is reserves. Oh, no. I think what it means is that it shows the reserves of each token. Yes. Okay. And users actually interact with spokes, which meanwhile are like able to interact with the liquidity hubs. Yeah, so let's just go ahead and dive in. So the liquidity management in RVV4 operates through coordinated interaction of liquidity hubs, spokes, and reserves, which I just mentioned. Understanding how these components work together is essential for grasping how capital flows throughout the protocol and how new markets can access established liquidity pool. Okay. Liquidity hubs are these where the actual liquidity uh, stays. Liquidity hubs are central settlement layer of Aave. Liquidity hubs are the central settlement layer of Aave. Each hub aggregates liquidity, manages. I'm not pretty sure whether the actual liquidity like resides under liquidity hubs or spokes, but I'm taking the best guess is that for sure liquidity hubs, and of course it has the word liquidity. The central settlement layer, yeah, okay, it does say here. Each hub aggregates liquidity, manages credits line, enforces risk parameters, and operates under governance control. Okay, this design allow new market to tap into uh, established pool without fragmented liquidity. Interesting. Um, so basically, and what they are saying is that liquidity hubs are the central settlement layer where the actual settlement happens, and each hub aggregates liquidity. I'm not pretty sure whether what does how does it work and what does it mean. So I do understand what does it mean in theory, but how does it work practically? So it manages credit line on how much borrowing and what is the actual gap of borrowing and lending. Borrowing and lending, yes, and enforcing risk parameters. This design allow new markets to tap into established pools without fragmented liquidity. Okay, so now we don't need to create actual like different pools for our same assets, which leads to fragmented liquidity, right? Assets are held at the liquidity hub, okay, which governs assets are held at the liquidity hub, which governs how spokes can access and utilize them. Governance defines liquidity caps. So we are talking about the liquidity caps and spokes basically. Governance defines liquidity cap, credit allocations, and risk parameter for each supported asset. Different hub types can be deployed for specific purposes, from conservative stablecoin liquidity to higher yield, higher risk configuration. Okay. Okay, let's just write it down because that'll make more sense for me personally. Can I'm not pretty sure whether. Okay, let it be. So let's do here. Oh yes, I forgot. Oh yes. Oh my god. Yeah, okay. This is making my life easier. Thank you, Google, for making this feature where I can like act like have a combined view of two different tabs. Now it makes my life easier, so I do not have to scroll back and forth, right? Let's let me just put it in a separate column. No, not this. And then I just do this. Yeah, so it is done. Liquidity hubs are settlement layer. Each hub. I think we did tracks accounting issues, credit line, debit lines, yes, and the risk parameters. I'll add that as well, and risk parameters. This allow. Okay, assets are held. Okay, let's write this down. Assets are held in liquidity hubs, which governs how spokes can access and which governs. I really don't understand like how does it work, like, so not really how it works, but so spokes also have like supply caps and like the local data, and it has accounting per spoke, right? But how would it work? Okay, my stream is going on. Cool. Assets are held in liquidity hub, which governs how spokes, which is how where the user interacts, how just a second if I can plot it down. Yeah, how spokes can access and utilize liquidity hubs. Okay, yeah, and governance defines liquidity caps, credit allocations, and risk parameters. Okay, and parameters within a liquidity hub like credit lines, risk params, and caps are defined by governance. Fair enough. Different hubs can be deployed for specific purposes, from conservative stablecoin liquidity to higher yield, higher risk configuration. Okay, and spokes are specialized smart contracts that connect to hubs. They define user-facing logic such as interest rate models. We read through interest rate models is basically uh, derived from how a utilization factor. So they are saying that they are just specialized contracts which define logic such as interest rate models, how much, and the collateral requirements and liquidation conditions on while liquidation condition while drawing on hub liquidity. Yeah. Okay, which is cool. Let's just do this. Spokes. Oh, wait a second. Oh my god, what the fuck is going on? The fuck is this? Spokes are contracts that define user-facing logics such as interest rates, comma, liquidation conditions, collateral requirement. What the fuck? Requirements and liquidation conditions. No man. Liquidation condition. This keeps the complexity of user interaction isolated. Okay, which is fair enough that you have dedicated section for to complicated user logics. Makes sense. Credit lines governs spoke access to hub assets, setting limits. Credit lines basically is defined on liquidity hubs. Governs spoke access to hub assets, setting limits and conditions for borrowing. A spoke may connect to multiple hubs, giving it flexibility to tap different risk profile or source of liquidity. Crucially, risks are isolated at the spoke level. Issues with a single spoke do not spread to hubs or other spokes, allowing innovation without systematic compromise, which is true. Reserves are managed at the spoke level and represent the accounting units for specific assets. So, okay, yeah. Okay, so reserves are managed at a spoke level. So reserves are managed under the level of spokes, which basically where the user interacts. They track deposits. Where were we? And represent reserves are managed at spoke level and represent the accounting unit for specific assets within each spoke. Okay, it basically tracks how much assets are deposited or borrowed under like specific spoke. They track deposit, borrows, repayments, and interest accrual while enforcing supply caps and user specific configurations, which is already we discussed. Governance defines how much of the hub's underlying token can be allocated to each spoke reserve through credit lines, adjusting dynamically based on demand and risk condition. Fair enough. Yeah. So Just be right back. Apologies. Yeah, so that is that. I think we have gone through getting started. Yeah, we did. We did went through getting started, liquidation model. Okay. We did also go through liquidation model. I'll just before I continue, I'll just I keep that in different sections for better visibility. And then we are moving towards user positions. So wallet creates positions like UA, and there are two type of position: borrowing and supplying. So we supply to Spoke, which basically supplies to liquidity hub, and when we provide collateral to the Spoke, it basically interacts with liquidity hub, borrows the relevant and stores the user position. Yeah, I think the accounting of tracking how much the user has borrowed is done under spokes basically. Not should not be like I think there should be an accounting for both of them, like a mapping of which spoke has borrowed uh, within liquidity hubs as well as like within the spoke as well. Yeah, but let's like I'm really not good at um, these lending and borrowing protocols, so I might be wrong here. A user position represents the complete financial state of a user within a specific spoke. Okay, tracking user supplies, user borrows alongside the key metrics such as health factor and risk premium. And by the way, risk premium is basically an extra premium that you need to pay based on the reputation of the collateral that you are providing, right? Unlike V3 where positions were per market, we position our per spoke, allowing users to manage different strategies and risk profile independently, which is cool. Yeah. In the Aave protocol, a user account often referred to simply as user. User account is often referred to as user is a single Ethereum address that has interacted with the protocol. Okay. User supplies. User supply represents. Oh, wait a sec. Yeah. Yeah, makes sense. Which is cool. And like, to be honest, I am. I've seen. I've tried reviewing a couple of DeFi related projects earlier as well, but I find the docs for Aave pretty straightforward here, and I'm very excited to dive into uh, the code for hubs and all. Yeah, I'm already browsing through the code. Just very like it seems something that like the docs are pretty straightforward, but I think the implementation would be definitely like so typical, because you are tracking a lot of data among like a variety of spokes, right? So a spoke is having a variety of data for different liquidity hubs, and same like vice versa. Yeah. So user supplies represent asset that a user has deposited into spoke. Each supply position. So supply is basically this one, not the borrow one. It accrues yield automatically through share based accounting that appreciates over time. So for those of you who doesn't know much about share based accounting, is that the protocol means share rather than the actual token itself. And when you are depositing, right, the protocol mints you shares. And when over the time, when the protocol earns yield, the share price will increase. And therefore you don't have to keep track of every user's interest. Rather, you need to only keep track of like how much the price of a share has increased over the time, uh, with, of course, in respect to yield, which is paid by the users that are borrowing. And then that is just simply the definition of share based accounting. And yeah, that is it. And the next point is can be enabled as collateral, to provide borrowing power based on the assets loan to value ratio. Okay, okay. So it's saying that uh, the shares that you mint can also be used as collateral within the platform, and it will give you the borrowing power based on the loan to value ratio. So how much like basically how much you can redeem on based on the value of or like how much percentage of the total deposit or collateral you can actually take as loan. Affects the risk premium when enabled as collateral. Riskier collateral affects the risk premium. Yep, affects the risk premium, which enable when enabled as collateral. Riskier collateral assets increase the overall risk profile of the position. Okay, so that can be withdrawn anytime provided the health factor remains above. Okay, I mean the okay, the health factor is only activated when the user, which is also having a supply position, or takes a borrowal out of the credit limits it has, the protocol has allowed him based on the position, like the share based position. Yeah, user borrows and this is we are just talking about the different type of positions. So borrow position represent the assets that the user has borrowed from a spoke. Remember that we talked about, like, the users are actually only talking to spoke. Each borrow position accumulate interest based on the assets borrow rate, increasing debt over time. Okay, and uh, that is that requires collateral backing according to the liquidation thresholds. um, liquidation. Okay, so it also requires collateral backing according to liquidation threshold, like what is how much you need to provide in, or like for some amount of money how much you actually need to provide such that your health factor remains above 1. And it impacts the health factor as a total part of debt. And user borrow position can be paid partially or fully at a time to reduce debt and free up some part of collateral if being filled partially. So what we get from here is that there are two type of positions. First is user supply, where you are providing supplies and it occurs yield over the time, and uh, user position are basically defined as share based accounting, which basically allows users to uh, like convert their shares to actual borrow position, and it can be all like withdrawn at any point in time, unless you are borrowing the assets based on that. And the opposite is user borrow position, where the user is actually landing sorry, not lending, but rather borrowing assets from the spoke, and it accrues yield over the period of time till you fully repaid. And it requires collateral backing, which we need to account for liquidation factors, such that the amount of collateral and the value of collateral needs to be above a liquidation threshold, such that the health factor is always above 1. And that's what we covered. And health factor is like calculated. Health factor is the factor, like, I think, yeah, just give me a second, I'm having tea at the same time. Yeah. Oh, sheesh, we have covered quite some ground. Yeah, if I was not streaming, I would have like just read these things and just give up the same time, because I try to understand by like making sure that my mind remembers it rather than taking notes, because that's how I used to work. But now, since I've started streaming, things are changing, and I'm like, I've gained a lot of I've covered a lot of ground by actually writing and documenting each and every source of knowledge that I've gathered, either by reviewing docs or reviewing the code bases. So I definitely highly recommend documenting and writing whatever you notice. Yeah, so the health factor is the core safety metric that determines a user position's liquidation risk. It measures the safe stability of users' positions, and the health factor is calculated by total collateral value, which is like the the value of the collateral the user is providing, weighted average collateral factor. I'm not pretty sure uh, what this is. Average collateral factor and total borrow value, which is like how much the user is trying to borrow. The health factor value determines the position safety status. The position is safe from liquidation. Below the become eligible for liquidation. Up to 50% of the debt, up to 50% can be repaid by liquidators. Up to, which is not exclusive. Sorry, this is exclusive. Up to 50% of the debt can be repaid by liquidators in order for extra. Sorry. And changes dynamically as the assets price fluctuate and interest occurs on both supplies and borrows. Um, Mm-hmm. Okay. Okay. Oh yeah. Okay, I understand. I'm still don't understanding the what is the actual weighted average collateral factor, but I'll just take a note of that and let's see how it goes. Do we have a math option here? Easy math? No, that's not it. Never mind. I'll just create it. And health factor. Maybe I can do health factor is basically total value multiplied by weight average collateral factor, and I'll just no I think I can draw a line here. Which is divided by total borrow value. Can I increase it a little bit? I think that'll make more sense. So a health factor is basically total collateral value, which is the user like the amount of or the worth of the collateral that the user is willing to provide, multiply by average collateral factor, which I don't know what it is, and divided by how much the user is borrowing, and which represents the health factor. But just a second, I need to draw a line here. I can do that. Yep. So this is it. Yep. Yeah. So I've understood, and also something above one, the health factor above one is really good. Below you're gone, and it changes dynamically as the price assets of the collateral, like the price of the collateral that you have deposited. And could be like the health factor can be improved if you repay the debt or provide more liquidity, and the new borrowing and other functionalities are only available if the health factor is above one. Yeah. And the other thing is risk premium, which represents the additional interest charge applied to borrowing based on the quality of the user's collateral. It determines how much extra user needs to pay on top of the base borrow rate. Base borrow rate is the rate that I think it is the in like base borrow rate should be like interest basically. A percentage value from 0 to 1000. Yeah, I'm quite confused about the risk premium, right? Yeah, so far we have covered a lot of ground. So based on collateral, a percentage value from 0 and risk premium based on collateral risk from 0 to 1000 that reflects how risky the asset of the collateral is weighted by a collateral amount calculated using only the collateral. Cross-spoke strategy for its modular design enables sophisticated position management across multiple spoke. Each spoke maintains independent risk parameters and liquidation logics. This means position in different spoke do not affect each other's health factor. This is important. So position in different spokes do not affect. So one position in one spoke does not invalidate or validate or modify basically other user position in different spokes. The user can hold conservative or aggressive position. Okay. Advanced spoke can access multiple hubs, enabling strategies such as collateralization assets from one hub to borrow from another. Okay. Accessing different okay, I get the gist that it basically allows a multi spoke functionality. And what is it? Tools. You don't need to review tools. Your reference. Wait a second. Yeah, I think we are good on understanding on what V4 is all about. So in the next stream we'll just dive into code and see what are our biggest assumptions, what did we get wrong, and how we can rectify our mistakes and basically learn, right? So see you in the next stream. Bye bye.